All right, guys, I'm sorry that I'm not here. I'm at an oh-so-fun math training, but I need to make sure that I don't let you get behind. So here comes a lesson on reference angles. So if you'll notice up here, I have four different angles where I want to find the cosine of each value. So I have my calculator, and I hope you can see it. I'm just going to quickly type those in and get these down to 4 decimal places. Cosine of 160. Again, you can do this on your own to sort of confirm. 9397. Cosine of 200. Negative 0.9397. That's kind of interesting, don't you think? 0.9397. Take a look at those. They're all unbelievably similar. So the question is, what is the connection between those 4 angles? So I'm going to try to draw all 4 of them. 20 degrees is here in the first quadrant. 160 is over here in the second quadrant. 200 is over here in the third quadrant. And 340 is in the fourth quadrant. So if you're asking yourself, what do these have in common? They have this angle in common. It's just in all 4 quadrants, okay? That angle, which has a measure of 20 degrees, is called the reference angle. That's what this is right here. I'm gonna scoot this up. Okay, so a reference angle is an acute angle. It's always going to be acute. Really, really, really important. An acute angle, and it has to be made with the x-axis. Made with the x-axis. Okay, and it's always going to be positive. You might kind of think of it as an absolute value. It's going to be positive. Even if it seems like the angle is being drawn in the negative direction, a reference angle will be positive. All right, so down here, and again, you have this paper, we're going to make a reference angle for each of the given angles, which means for me, drawing a picture of each one and seeing if I can find an acute angle made with the x-axis and have it be positive. All right, so 5 pi over 6 is just a little less than 1, so it's this angle right here, which means my reference angle is right here. So the question is, how far away am I from 1 full pi? I am pi over 6 away from getting all the way over there. That shaded area is pi over 6. That is the reference angle. So here, 5 pi over 4, let's see, that's more than 1. So that means it's over here in this quadrant, right? It's all the way to here. That is 5 pi over 4. But the reference angle is this little shaded one, right? It's the acute angle made with the x-axis. So the question is, how many radians are in there? Well, all the way to here is 1 pi. So this is just a little bit more than we went, which was pi over 4. That's the reference angle. All right, negative 19 pi over 3. That's negative 6 1/3. That sounds about right. So let's see, starting here, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and 1/3 more. So there's a picture of it, right? I didn't draw in all the rotations, but this is the reference angle. So the question is, how far did we go to draw that? We went pi over 3. Okay, so are you noticing anything with these examples that the reference angle has the same denominator? Well, in this case, it would be, it's way over here. And then same denominator, right? Usually the denominator, there are exceptions to this rule, but usually the denominator will give you a big hint as far as what the reference angle is. All right, so now let's switch over to degrees. Okay, so 150 degrees. Again, if I draw that is here in the second quadrant. This is 150. So the question is, how much is it here? That's the acute angle made with the x-axis. That would be 30 degrees. Okay, for this one, 92. Let me draw. Ooh, 92 is actually hardly anything past 90. Now, if you're looking at that, you may see a very, very, very acute angle. You may actually shade in the wrong one because this is the acute angle made with the x-axis. How many degrees are there in that? 88 degrees. Okay, so it's not a question of which one is acuter. I know that's not a word. More acute. It's the one that's made with the x-axis. All right, so likewise with this 270, when I draw that, it's right here in the fourth quadrant. And even though this is, you know, kind of a smaller angle than this is the reference angle. all right, which is 80 degrees. All right, hopefully that all makes sense. I have a second side to this. I want you to really, really look in this box up here. Just a reminder about what angle measures are in the first quadrant, second quadrant, third, and fourth. All right, because there's some directions. I'll let you read the directions. Okay, so my worksheet that I had handed out to you has a typo. So if you can see what I've added here, the quadrant 3 and the quadrant 4, add those to your worksheet. So when I go to my calculator and I hit second sine of negative 0.6691, the angle that my calculator is telling me, and I'm gonna draw a picture of it, is this, negative, I'm just gonna round to the nearest degree, negative 42 degrees. Okay, negative 42 degrees is not in the third quadrant, right? I drew a picture of it. Clearly it's not. So what this is the reference angle. See how it's acute and it's made with the x-axis? It's the reference angle. So I'm gonna draw it in the appropriate quadrant. This is quadrant 3. This has a measure of 42. And I'm gonna try to find this angle, right? Because in quadrant 3, right, my answer should be something between 180 and 270. So if I take 180 and I add 42, I get an angle of 222 degrees. Okay, what's cool, I can check this. If I do the sine of 222, I should get that decimal, right? So again, there's always a way to check. So let's try this one. If I do second cosine of 0.2588. My calculator says that this angle is 75 degrees. Here's a picture of 75 degrees. Is that in quadrant 4? Well, no, it's not. So that's the reference angle. Let me draw it in the fourth quadrant. Here it is. But I want this measure, right? Because that's the only way I'm gonna get an angle over here between 270 and 360 is if I go all the way around. So 360 minus 75 gives me an angle of 285 degrees. And again, you can check that. If I did cosine of that answer, I should get this decimal, which I do. It's rounded, but I do. All right, and then this last one, you've seen problems like this. You saw them on Friday, but I just want to make sure you have a little bit more practice on them. The terminal side of theta passes through the given point. Let me draw a picture of that. So 3, -6 is down here in the fourth quadrant. 3, -6. Theta is going to be the acute angle made with the x-axis, always. And we want the values of the 6 trig functions. It's going to be a ratio simplified. Ooh, how cool is this? Look, not rationalized. Okay, that'll save you some time. So I just need the missing side, the hypotenuse. 3 squared plus -6 squared should equal the hypotenuse squared. 9 plus 36 is the hypotenuse squared. 45 is the hypotenuse squared. H is the square root of 45, or 3 rad 5. 3 rad 5. Okay, so then we can fill this in, and notice it wants us to figure out what theta is. So let's see. Sine is opposite, -6, over hypotenuse, 3 rad 5. So I don't have to rationalize, but they do want it simplified. So I do need to reduce, -2 over rad 5, which means this one's really easy. I just flip that one over. Okay, cosine is adjacent over hypotenuse, which is 1 over rad 5, which makes this, again, unbelievably easy when you flip it over. Tangent is opposite over adjacent, in this case, -2. That makes this -1/2. And then I can pick any of these, right? I can pick any of these to put in my calculator to get the angle. I think I'm gonna do the tangent. So second tangent of -2 gives me this angle of -63, which again, I like, except that I want an angle in the fourth quadrant, meaning, again, going back to this, it has to be between 270 and 360. So I'm looking for this. So if I do 360 minus 63, I should get an angle of 297. Thanks for watching. See you tomorrow. Be good for the sub.